Hi, so today we will be continuing our lesson, and this time we will be working at 1.2. This is called Estimation, Graphs, and Mathematical Models. So for this topic, our learning objectives include the use of estimation techniques to give an approximate answer to a problem, also estimation techniques to information given by graphs, and lastly, we will be able to develop mathematical models that estimate relationships between variables. Now, there are three methods of estimation. Now, before we continue with that, when we say estimation, we are pretty much giving an approximate answer. So we are trying to give something that is a little bit near the value, because sometimes the real value might be too complex, or it could not be it's difficult to represent, and so we will have a different number that will represent that exact value, but the estimated value, the approximate value, will not be too far from the real one. Okay, so we have three methods of estimation. We have rounding numbers, using graphs, and using mathematical models. So we will go through each of this in this presentation. So I believe you have done rounding whole numbers or rounding numbers in your earlier math classes. So when we talk about rounding whole numbers, so we pretty much look at the digit to the right of the digit where the rounding is to occur. Now we have two rules to follow when it comes to rounding up or rounding numbers. Okay, so we have if the digit beside the place value that we need to round, if it is greater than 5 or greater, then that digit will increase by 1. If the digit is less than 5, then the digit is maintained. All right, so you will see that the symbol like this, it's like a curly equal sign. That is the symbol for approximately equal to. So let's have some examples here. So in this given situation, the population of the world is 7,058,746,857. So as you can see, there's like lots of different digits here. So we can give an approximation if we try to round it to the nearest 100 million. Okay. Now, if you go back to your basics with the place values, so these are your units, these are your thousands. So the millions are this group. So 100 million is gonna be the 0. Okay? So our question is, will 0 remain by itself as 0, or will it change to 1? Because remember, we need to look at the digit to its right. So in this case, we are going to refer at number 5 here. It's the one right beside it. So is this digit greater than or equal to 5? Yes. So it means that this 0 will be increased by 1. All right. So our approximate value, the rounded value here, would be 7 billion. Now this 0 will change to a 1. And then all other digits will just be replaced by 0. So 100, then you have 3 zeros, and then additional 3 zeros. So this value, 7,058,746,857, can be rounded as 7,100,000,000. Okay, so as you can see, I think it's a little bit prettier than that number, since you have just 2 digits to actually enunciate, and then the rest are zeros. All right, let's have the next example. We have to round this off to the nearest million. So again, these are your units, thousands, and then the third group, that is our millions. Excuse me. So our millions digit is 8. So we gotta check the digit next to it. So we'll look at this one to its right. Now we can see that it is a 7. So given that this digit is it greater than or less than 5? 7 is greater than 5, which means what will happen to 8? Is it going to change to 9 or is it going to stay as 8? So this is higher than 5, so this means that the 8 will change to a 9. So we write these numbers here, so it's going to be 7, 0, 5. The 8 will change to a 9, and then all the rest of them becomes 0. All right, so this is now 7,059,000,000. That is our rounded value. And then I think this is the last example for this number. So now we have to look for the nearest 100,000. So again, these are your units. These are your thousands. So you're going to look for the 100,000. So it's always, this is the unit 1,000, this is the 10,000, this is the 100,000. So we're going to check if 7 stays or it will increase by 1. So we will refer to the digit to its right, which is a 4. Is it greater than or less than 5? 4 is less than. So 7 is now going to stay as it is. Okay? So because this digit is not greater than 5, the actual digit that we're looking at here will remain. So we copy the rest on its left. So it's 7,058. So 7 stays as it is, and then everything else after it becomes a 0. Okay? So always remember, you make sure that you understand, you reflect on what place value was being used. All right? And make sure that you identify that place value. And after that, you take a look to the digit on its right and determine if that digit in the given place value will be kept as it is or if it will increase by 1. All right? So let's have this next example. We have to do some rounding of the decimal part of a number. So let's make use of the value of pi, which is 3.141592. Actually, there's more to it, but we will just consider the first 7 digits. So first thing, we need to round off to the nearest hundredth. So if we're going to review the place values on decimal part, you always start the first digit next to the decimal point is your tenths with a th, tenths value. So tenth, hundredth, thousandth, 10,000, and so on and so forth. So if we're looking for the hundredth digit, so we need to look at the digit 4 over here. Oops, sorry. Let's put that over here. So 4 is the digit that we are concerned with. Is it going to stay as 4 or are we going to increase it by 5? So we look to its neighbor number digit, which is a 1. Because 1 is less than 5, then 4 stays as it is. So rounding to the nearest hundredth would be 3.14. Now, Miss, do we need to put the zeros afterwards because there are still some digits in here? If we are rounding off decimal part, we don't need to put the rest of the digits as 0. We basically use the numbers or the digits up to the given place value that was mentioned. All right? So in this case, we need to round off to the nearest thousand. So again, this is your decimal point. So this is tenth, hundredth, thousandths. Okay? So we need to check, is this going to stay as a 1 or will it increase to 2? Looking at our neighbor digit, which happens to be a 5, because it's equal to or greater than 5, then the 1 will increase by 1. And so we will write this as 3.14. This number 1 here, this digit 1, will now become a 2. All right? So how can we use estimation in real life situation? Well, one of the best ways to do this is when you are shopping, okay? I know before people would say you will not have your calculator all the time, but that is not the case right now because your phones always have the calculator. But then you don't need to bring out your calculator all the time because you can make an estimate. This is something that it is a skill that you can do easily. Okay, so in this scenario, you purchase burger for $2.59, detergent for $2.17, sandwich for $3.65, apple for 47 cents, and coffee for $5.79. Now, according to the cashier, you had to pay a total of $18.67. All right. So if you are somebody who doesn't care with money, then you just pay the whole thing. But obviously, we need to be smart, especially with the amount that we are spending. So let's check if it is reasonable. So for you to be able to do it quickly, what we can do is to round off each of these costs to a whole number, to $1. Okay? So let's have the detergent. The detergent is $2.59. So let's just give it as a $3. Okay? Our sandwich, sorry, the bread, my bad. This is the bread. That's the bread. And then the detergent is at $2.17. So $2.17 is much nearer to $2. Okay. Sandwich is for $3.65. So sandwich, it's closer to $4. Okay. Apple is 47 cents. So the apple, we can round it off to the nearest cent. So let's have 50 cents. That's an easy add. And then the coffee is around $5.79. So let's put it up to $6. Okay. If you do a quick math on this, 3 and 2, that's a 5, and then a 4, which is a 9, 9.50, and then you have a $6. So roughly, you should just be paying around $15.50. Okay. Now, if you would consider, miss, if these costs already includes the taxes in them, then 1867 is quite high. All right, that would be questionable. But because when we are buying stuff, there will always be a sales tax on the top. So if you add some sales tax, let's say another $2 or so, then probably an 1867 would be it depends on the sales tax. Okay, so if the sales tax is higher, if the sales tax is, let's say, $1.50, then 1867 is still high. If the sales tax is a high value, let's say it's a $3 sales tax, then probably the 1867 would be reasonable. Okay, so estimation in real life is going to be very useful, although I know that it is already common for everybody to have calculators. So I guess that would be an easy thing to make sure or double check the cost that you are paying. Okay.